Hi friends, welcome back. Today we are going to solve Leetcode problem 1284, minimum number of leaps to convert binary matrix to zero matrix. This is one of those hard problems on Leetcode, and you can see from like dislike ratio that this is a very likable problem. So in today's session we will go through this problem. We will understand the logic how we can solve this problem, and we will implement the solution using Java, and we will discuss that also at the same time. Before we start looking the details, I want to mention that my channel is dedicated to help people who are preparing for Java GTUI and coding interviews. On my channel, you will find lots of helpful videos that can help your Java and coding interview preparation. There are over 400 different varieties of problems which are coding interview questions taken from previously asked questions by big tech companies such as Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big financial clients. Those coding interview questions are very important in the sense that they constitute very important wide range of coding varieties that you will generally encounter in your coding online coding interviews as well as in-person coding interviews. That varieties include BFS, DFS, matrix problems, graph problems, coding questions related to binary search trees, strings, linked list, optimization problems using priority queues, as well as problems using dynamic programming, and lots of logical questions that can be solved with the help of different data structures such as sets, maps, queues, stacks. So on this channel you will find lots of vast varieties which will be very helpful for you to practice for your coding questions, as well as there are there are videos to help your Java J2E interviews as well. So please subscribe to this channel now. So let's start with our hard problem today, 1284, minimum number of leaps to convert binary matrix to zero matrix. Given m by n binary matrix mat, in one step you will choose one cell and flip it and all four neighbors of it if they exist. Flip means changing 1 to 0 and 0 to 1. A pair of cells are called neighbors if they share one edge. Correct. So what it means, what they are trying to say, I'll just show you in this one example, is that, for example, if let's say this is our matrix, let's say, right, and this is our cell, correct, this is our cell of matrix, then we have to consider these four cells basically, right? So these are the adjacent cells basically, right? 1 2 3 4, right? These are the neighbors basically for this cell. So if we are changing, let's say this is 1 for example, and these are all zeros for example, just assume that all are zeros. So if we are changing this one into 0, one flip means this is changing this 1 to 0 and all this 0 to 1 basically, right? All this 0 to 1. So this is called as one flip basically, right? So this is what they are saying. So return minimum number of steps required to convert matrix into zero matrix or -1 if we cannot convert it. A binary matrix is a matrix with all zeros and one only. A zero matrix is a matrix with all zeros, right? So this is what the problem statement says. So we will go through one example and we will understand this problem, and then we'll look into some other examples as well, and then we will formulate our solution, right? So as I explained you, this is the idea of flip, right? So flip in four directions, correct? So you got the idea of flip. So this is called as one flip basically, right? One flip, right? So we have to find out the minimum number of flips so that we can turn this 111 matrix, means this input matrix, to all zero matrix. All zero matrix means all the cells should be converted to zero, right? So I'll just remove this flip. So you got the idea of what flip means. Now let's just remove this thing. So flip means all four directions, right? So let's say this is our input matrix, right? So 111 is our input matrix, correct? So this is our input matrix given to us, and we have to find out the minimum number of flips so that we can convert this matrix into zero matrix, correct? So what we can do, let's first understand a few examples so you will be clear about the problem, and then we'll go through the solution. So this is the input matrix, right? So what we will do to convert it into 0 matrix is, first thing is we will take this cell, right? So we are taking this cell and we are flipping it. So now after flip, what we will flip? So this red color cell we will flip, and these two neighbors we have to flip, correct? Because other two neighbors are not existing, so whatever is existing we have to flip. So these three ones that I highlighted, 1 1 1, will become 0 in one flip, right? So this is what matrix we will get, right? This matrix we will get, correct? After one flip we will get this matrix. So this is after one flip. So this is one flip, right? All these are zeros now. So now after that we will take this matrix, new matrix, and again we will do a flip on this one, right? On this one we will do a flip, which means that it will convert this one as well as these two ones to 0, correct? Because they are the two neighbors. As I showed you before, we have to consider the four neighboring cells, right? So whatever is existing we will consider. So this is existing cell, so we'll convert these all ones to zeros. So now after conversion, this is what we will have, correct? So all these ones will be converted to 0, right? So this is one more flip we are doing, correct? So one more flip we are doing. So total number of flips we have done is 2, correct? And we have converted this input matrix into 0 matrix. So as you can see, all the cells are now 0, correct? So we have to return this 2 as the answer. Basically this is the minimum number of flips we can take, right? There might be other combinations, but it might take you more flips, right? We have to find out minimum number of flips. That is a very important thing, right? This minimum number, as you can see, right, they have tilted it. So this is a very important thing of steps we have to find, correct? So this is what the problem is, right? So the problem statement is pretty clear, so there is no kind of confusion or anything, right? So they have given us one sample. So let's take some other examples also, right? This is one other example, right? So where this is the input matrix that is given to us, correct? So you can just say that this is the matrix 1 0 0 and 1 1 0, right? We have to convert it into all 0 matrix. So as you can see, we can just take this one, correct? And then we will do a flip. So with this one, what other ones we will do? We will do its neighbors, right? So this is a neighbor and this is a neighbor, right? Vertical and horizontal, right? So we will flip it. So after this flip, you will get what you will get, like 0 0 0 and 0 0 0, correct? 0 0 0 you will get. So after the flip with this one, correct? This one. So we actually did one flip and we got all the 0 matrix, right? So we have to just return 1 as our answer, because in minimum number of flips, right? So 1 is the minimum number of flip we can use actually to get all the zeros, correct? After that, if you consider this another example, right? So this another example, let's see this and then we'll go through our approach how we can solve this problem, right? So as I showed you, this is the input matrix. So you can just assume that this is our input matrix. So what we will do in this case is, we are actually taking, let's say, right, 1 1 1. So we have taken this become 1, so this become 1, right? So 1 1 0. So we have basically taken this 0, correct, in the first case, and then after this 0 will become 1 and its neighbor become flipped also. Neighbor will also be flipped, right? So this 0 will become 1, this 1 will become 0, and this 0 will become 1, correct? So this one, now we will get this as our resultant matrix after one flip, right? So I highlighted you which cell we are flipping, correct? This cell we are flipping from 0 to 1. So neighbor means 4 neighbors, right? So whatever is available, so these are available, so we are flipping it basically. So 1 becomes 0, this 0 becomes 1, this 0 becomes 1, and this 0 became 1, correct? So after one flip, so we did this one flip now, correct? We went here. Now again we have to do one more flip. So now we will take this one to flip, right? We will take this one to flip. So if I flip this one, then I will flip the neighbors. These ones also I have to flip, correct? So after the flipping, how it will become, all this one will become 0, right? 0 0 0 0, and this is already 0, right? So this is our resultant matrix after the second flip with this one, right? Correct. So this is our second flip now, right? And after the second flip, now what we will do is we will take this one, correct, and then we will do a flip. So again the neighbors we will flip is this one, right? So now it will become 0 0 0 0 and 0 0 0 0, correct. So this is the result of the third flip, right? From this state of the matrix we will go to this next state, you can say, right? It's kind of a state, you can assume, right? So this one is a minimum number of steps are 3 to reach to 0 matrix. So that one we have to output as our minimum number of steps to reach to 0 matrix from the given matrix, right? For this example. So from all these examples, it's pretty clear to you what the problem is, and how, like, we have to properly choose 0, which, I mean, sorry, we have to properly choose a cell which you will flip, right? If we choose proper cells, then we will reach there in a minimum number of time, right? Whenever a question comes generally with kind of minimum number of steps, something like minimum, right? So always first we have to think like, is if this kind of questions we can generally be able to solve using BFS, right? BFS, breadth first search or breadth first traversal, correct? So what we can do is we can use a technique called as BFS, right? Breadth first search or breadth first traversal, correct? And generally BFS uses Q, correct? BFS uses Q, right? So what we can do, so let's take this example that they have given us, right? For example 0001. So what I mean to say is this one is our given matrix, correct? This one is our given matrix. So what we will do is, in the BFS, is we will take each of these cells and we will flip it, right? Each of this cell and we will flip it. For example, first I take this cell, I flipped it, right? So I get this one after flipping. The next I am taking this cell, again I am flipping, so I'll get like this basically, right? After flipping I'll get this. Then I will take this cell, correct, and I will try to flip it. After flipping I'll get like this, right? As you can see, right, 1 1 and 0 it will become, correct? 1 1 and 0. So this is the result, and after that last one I'll take this cell and I'll try to flip it. So now I have, from this is m by, like, or you can say n by n matrix, right? So the output of, in one step of BFS we will get n into n different matrices, right? So these are n into n. So this is 2 by 2 matrix. So we will get 4 different matrix, right? 4 different matrix. You see, these are, what I mean to say is these are all 4 matrix, right? These are all 4 matrix, correct? We got, in one iteration we got 4, right? For one we get 4 basically, because we have a choice to turn out, like, to flip every cell. Now how many cells we have? 4 cells. So it means in one matrix we have 4 cells, which means that from one matrix we can get 4 different matrices, right, after flipping, correct? So this is how our flipping will work in BFS. So I'll just remove the all this coloring. So this is our first iteration, right, and we will get all these kind of matrices after flipping, correct? And what we will do is we will keep checking if we are reaching us all 0 matrix, right? So we did not reach all 0 matrix. So now what we will do in BFS, we will take each of this matrix and we will again run the BFS on it. So each matrix will generate 4 more matrix. For example, if I take this first matrix, it will generate this 4 matrix, right? It will generate this 4 matrix, correct? Like this basically, right? If I take this next one, it will again generate 4. If I take next one, again 4. If I take this next one, again 4. So for this 4 we will get total 16 generated matrices, right, with BFS approach. And at the same time we will keep checking if we get a matrix with all the zeros, right? So this is the way it assures us, the BFS assures us that we will reach to all zero matrices within minimum number of time or minimum number of steps, right? So that is why the BFS is very popular technique for this kind of problems, to find out a minimum steps, minimum number of time, right? So you got the idea. So we'll take this input matrix, we will use a BFS, we'll generate these matrices, and always we'll keep checking if we have reached our destination matrix. Our destination matrix for this input matrix is what will be our destination matrix? All zeros, right? All zeros is our destination matrix. If we reach this, we will stop, right? And we'll just return the number of steps we have taken to reach it, right? So from this one, this generation of 4 is one step basically, right? From this 4, if I am generating the next 16, then that will be second step, correct? So for like this, for in this case we will take it will need 3 steps. They have shown us how the 3 steps will be needed. You can take a look here, and we will reach this all zero matrices, right? So I have shown you a couple of other examples also how we can reach all zero matrices, right? Like for example, these examples we have seen how we can reach all zero matrix, right? So this is our solution. Our solution will be based on BFS, which is called as breadth first search or breadth first traverser as well, right? And it uses queue. You got the idea how we can solve this problem, I think. So we can more understand with the Java code now. So let's go to the Java solution for this problem. Yeah, so this is our Java solution. So I first implemented a wrapper class. The wrapper class will take the matrix and its number of steps, correct, that we have taken so far. So we will wrap this information with this class state wrapper, and this is our constructor for the class. We have implemented equals method, right? So whenever we are implementing equals method, we wanted to this is our object, right? Equals method always get objects, as you can see. So we have to equate with this matrix, right? So what we will do is we will use arrays deep equals method, correct, with the incoming object, which is data. So data dot matrix, with the current matrix we have to use arrays dot deep equals method, right? So it will deep equals method is useful for like 2D or more than that kind of arrays, right? Because it will compare each of the element of the 2D arrays, for example in this case, with the other 2D array, right? Every element it will compare and it will tell us if both the arrays are equal or not. So this one you can find out in the Java docs, right? Java documents in Oracle. So here this deep equals method, it will take two arrays here, right? And it returns true if two specified arrays are deeply equal to one another, right? So what it means is it is appropriate for use with nested arrays of arbitrary depth, right? So that's what they are saying. So it will compare each of the element. Two array references are considered deeply equal if both are null or if they refer to arrays that contain same number of elements and all corresponding pairs are deeply equal, means their values are also equal, right? So that deep arrays deep equals method we will use, right? So this is the let me show you. So this is from the arrays class, right? So if you go java.util has a arrays class, so that's very handy method. You can take a look at the Java documentation, but that's what we will use, okay? And then we will also use the deep hash code method from the to calculate the hash code of the matrix, right? It's also in the arrays class. So so this is our first state wrapper class that we will use in our solution. So I showed you that. Now we have one helper method which will check if the cell is within the boundary of the matrix, right? So this is the helper method, cell inside matrix. So this is our original method min flips, right? So mat is the two-dimensional matrix that will get as an input. We will create a queue of state wrapper objects, right? This is a state wrapper class that I showed you. So queue will take the objects of state wrapper class, right? And first we will start with a state wrapper class with the given matrix, and number of steps in the beginning is 0, right? Because we have not taken any step yet. So that is our starting point for the BFS. the destination here, we are going to create a destination matrix of the same size as the original matrix. So as I shown you, so this is a 2 by 2 matrix, right, originally. So we have created a 2 by 2 matrix with all zeros, right, because this is what our destination matrix is, correct. So that's what we are creating here, destination matrix, and we are just filling it with zeros, correct. After that, we will just make a set of state wrapper objects, so that we will know that we have already visited that uh, state wrapper object, right. So we don't want to recalculate or revisit the same cells. Basically, for that we will use this uh, visited array, right. Oh, sorry, visited hash set, right. After that, this is the point where our BFS starts now, right. So BFS starts here. So this will be done like this. While loop will continue until the queue becomes empty, right. So as long as there is something in the queue, it will keep doing the BFS, right. So first we will call the current element from BFS, right, and then we'll get the state wrapper class. Then what we will do is, first thing we always wanted to do is the state wrapper class has a matrix, right, because as you can see, it has two things, matrix and number of steps. So matrix and number of steps, correct. So once we get this uh, uh, state wrapper object from the queue, first thing we will wanted to do is, did we reach our destination, right, did we reach our destination matrix. So that's what we will check using the arrays deep equals, correct. We will pass the current objects matrix and the destination matrix that we have created here, correct. So if we reach the destination, then we have to just say current dot steps. So because that is how many steps we have taken to reach to the destination, right. If that is not the case, we will check if we have already visited the current matrix, the current state, basically, right. This is the current state object, you can say, right. So we will check if we have already visited that. If not, then we wanted to visit it, so we will just add it into the visited set here. And we have the 4 directions, correct, because we have to do the flip in 4 directions. So that's why we will use these 4 directions. So first thing is, we will copy from the current matrix using the arrays stream, right. So if you are familiar with Java 8 streams, then that's what we have used here. And then we'll just use the map, so that we will actually, we don't want to change the actual state of the current matrix, right. That's why we are just doing the this getting the stream and then mapping it to the array, so that we will get a copy of the matrix, right. So this is where we are getting the copy. We'll just call it as a copy here, and kind of cloning, right. So copy, we will get it, and then we will start doing the simulation that on the copy, basically, right. We will have to simulate in 4 directions, correct. So 4 directions. So this is where our simulation starts, right. So we will go from, I goes from 0 to the number of rows, right. Current matrix dot length is the number of rows, and this is the number of columns, correct. So this is what we are doing in the 2 for loops. We will go in each cell of this current matrix, correct, each cell of the current matrix, and we will try to flip it, correct. So as I showed you here, so each cell we have taken, right. First let me just remove these colors. So I'll just remove these colors so that like this one become red. Yeah, so what I mean to say is, each cell we will take, right. First this cell, then this cell, then this cell, then this cell, and we will keep generating this matrix. So this is, for example, for this cell, this first matrix, right, we generated. For this next cell, this second matrix we generated after flipping, right. For this cell, we generated this after flipping, and for this cell we generated this after flipping. As you can see, for the last one, for example, if I flip this 1 to 0, then this will become 1, this will become 1, right. As you can see, 1 1 and 0, right. So we are taking each of the cell of the matrix and we are flipping it. So that's what simulation we are doing here, correct. We'll flip on 4 directions, 4 neighborhood, right, neighbors. And we first wanted to also, before we do the flipping also, we have to make sure that this next row and column position that we are generating, it should be inside the matrix, right. Then only it makes sense to flip, right. Otherwise we will not flip if it is going outside of the matrix, right. So this thing actually is just like doing the flipping thing for all the cells. After that, we will just say this copy ij is equal to 1 minus copy of ij, and then we will add into the queue the new state of the matrix, right? This is the new step of the matrix with number of rows, number of steps will be previous step plus 1, correct? Because we are taking one more step. So this copy will be our new matrix, right? New matrix. For example, from this I generated this matrix, so I will put this into the queue, then this into the queue, then this into the queue, then this into the queue, right? So that's what. And the thing is, number of steps were 0 here. Here I will put number of step as a 1, correct? Because this is one more step we have taken to reach here, correct? So that's what we are doing here. And then we will just do this copy of current matrix. So we are just cloning it basically, correct? um, so this one we will keep doing it, this whole thing, until uh, the queue becomes empty, or if we find out our destination matrix. If we find out our destination matrix here, we will just return the number of steps we have taken to reach there, right? Current object that we are getting from the queue polling means we are removing from the queue here, right? The object, state wrapper object. So state wrapper object will have the new matrix and the number of steps we have taken to reach there, right? So that's what we have to return here if we find out the if we reach the destination matrix, right? If we cannot reach it throughout this while loop, then at the end we will come here and will return -1. It means that we cannot convert that matrix into all zero matrix, right? So I got like you got the idea of how we can do it, right? So I showed you this example, I think here, yeah, here, right? 2 steps. So let's go ahead and take a run this code and make sure we get 2 steps. So we are getting 2 steps, which is the correct answer, right? After that I created a few examples for you. So let us just take some examples here. So this is one of the example, right? So I'll just copy and paste this example. So this we have seen, I think. Yeah, this example we have seen, right? 100 110 100 110. So in one step we, this example, right? In one step we can convert it. So let's make sure this works. So this works, we are getting correct answer. After that, let's take this example, which is the given example. They have said it takes 3 steps for that. So let's make sure it takes 3 steps. So 3 steps, we are getting correct answer. Then let's consider one negative test case. So this is negative test case where we cannot convert it into the all zero matrix. So it should give us -1. So it is giving us correct answer -1, right? So let's just finally use all these examples. 30 -1 30 -1. So we are getting all correct answers. So we can submit our solution now and make sure it's accepted. So our solution got accepted by Leetcode, as you can see. This is one of the hard questions on Leetcode, the minimum number of leaps to convert binary matrix to zero matrix, right? Our solution is accepted. And I showed you already in details how our solution works with the help of BFS and Q. And you also may want to take a look at the Java util arrays class methods. We use the method to copy, like to create the hash code, as well as to copy the check the equality of the matrices, right? So both these methods you wanted to take a look at, right? Because that will be very helpful. This method deep equals, right, that we have seen here, and deep hash code, right? So if you are new to my channel, there is a dedicated playlist on my channel called as Leetcode and Leetcode Solutions. There are over 200 different varieties of problems, which are coding questions asked by Amazon, Apple, Google, Facebook, Microsoft, Yahoo, and many other big financial tech clients. Apart from this, there are 3 other main coding playlists you wanted to go through on my channel. The names are Code Forces, Code Chef, and AdCoder. All in all, there are over 400 different varieties of coding problems that if you like wanted to prepare for your coding interviews, if you go through those problems, will definitely be help you in your understanding of how you can approach and solve different coding problems with the help of different data structures and with the help of different techniques, right? Because if the more problem you solve, the better for you in your coding interview case, right? Because you know what techniques we can apply to solve different varieties of problems, right? So for example, in this case we use the technique BFS, right? Breadth first search, because you know, like more problems you solve, you will understand from that what techniques and how we can solve different problems. If you like this video, if you find this video helpful, and if this if you like the way this video has been created with the help of whiteboarding session, examples and Java code, then please give it a thumbs up or give it a like. Also share this video with your friends and colleagues who might be preparing for coding interviews. They can also go through these videos and get helped by watching these videos in their coding and Java interview preparation. uh, if you like this video, and if this video help you in understanding this problem, this hard problem, in a easier and better way, then please give it a thumbs up and give it a like. Also, if you have any questions related to this problem or this video, then put your questions below the description section. The Java solution that we have seen here, this solution, I am going to put this code on my GitHub project. You can check out the code from my GitHub project and play with the code with different unit test cases for your better understanding. And you can also practice with this kind of, like, with lot of examples or solutions are there. You can practice those solutions. And if you like my Java solution, then please consider giving it a star on my GitHub project. That might be helpful. Keep coding. The more you keep coding, more problems you keep solving, the better you will become at solving the problems and coding questions. There are also videos for your interview, like telephonic and initial round preparation for Java interviews. The playlist is called as Java interviews. You can check it out. There are a couple of videos there. There are also videos related to Java architecture, design patterns, as well as Java string coding questions that are asked previously on telephonic rounds. So you might want to check it out. Thanks for watching this video.